Welcome to an introductory unit on graph theory. In this video, we will be going through some of the basic definitions and terminology that relate to graph theory. To introduce the concept of graph theory, let's take a look at a problem that can be solved using graph theory. So in a group of 7 people, is it possible for every person to shake hands an odd number of times? So in graph theory, often what we do is we represent things using vertices or dots and edges or lines connecting vertices together. So for example, let's let some dots here. Let's let those dots represent our 7 people. And then I will connect 2 dots or vertices together to represent a handshake that has taken place between those people. So the goal is to have everybody shake hands an odd number of times. So for example, let's say persons 1 and 2 shake hands, giving them 1 handshake, an odd number. We'll let 3 and 4 shake hands, also an odd number of handshakes. And we'll let 5 and 6 shake hands to give them each an odd number of handshakes. So everybody has shaken hands an odd number of times except for person number 7, who has not yet shaken hands, and 0 is an even number. So person number 7 needs to shake hands with someone. So let's say person 7 shakes hands with person 1. Well, when that happens, notice that person 1 has now shaken hands twice. They have shaken hands with person number 2 and with person number 7. So person 1 now has an even number of handshakes. Well, we've got to take care of that problem. So person 1 is going to have to shake hands with someone else. Let's just say, for example, person 1 shake hands with number 6. Well, now what has happened is number 6 now has an even number of handshakes. Person 6 has shaken hands with persons 1 and 5. If I'm going to turn 6 into an odd number of handshakes, I have to have them shake hands with someone else. So let's have them shake hands with, say person number 5 a second time. Well, now 6 has shaken hands an odd number of times, but 5 is right back to even. They have shaken hands 2 times with the same person, number 6. And I think you can probably see what happens as we continue this. As we turn 5 into an odd number of handshakes, that sends somebody else into an even number. And now 4 is even, and you can continue this pattern as much as you want, but what happens is every time you go to turn 1 into an odd, the remaining even into an odd, you then turn an even back into an odd, and so what we discover is that this situation is impossible. But using a graph, like I just did with vertices and edges, is one of the best ways to depict or to model this situation. And this is one of the scenarios that graph theory can be applied to. So let's look at some vocabulary, and we'll also relate it back to that example that we just did about the handshakes. So when we have a vertex or vertices, which is the plural, those are represented by the dots. And those dots can represent a number of things in terms of a scenario that we're actually trying to model. So in the previous problem, the vertices represented the people. It could be that a vertex represents a house in a given neighborhood or on a street. A vertex could represent maybe a series of classes that are being taken by college students. There are numbers of things that vertices can represent. But in each case, we use a dot to represent that vertex. An edge is a line that connects any 2 vertices. Okay, so a line that connects vertices. Lines do not have to be straight. Okay, so for example, I could add another edge between B and D, and so that would just mean there are 2 different ways that I could travel from B to D. And that's perfectly fine. So you can have multiple edges between the same 2 vertices. A connected graph means that the graph is all in one piece. Okay, so connected, the graph is all one piece. A disconnected graph would mean that your graph is in more than one piece. So let me real quick draw you an example of a disconnected graph. That would be an example of a disconnected graph, because I think you can see here by looking at what's going on is we have one piece of the graph there and we have a separate piece of the graph, so that if you're going to pick up one piece, it is definitely not connected together. Okay. A loop is this circle right here that goes around at G. Okay, so it is an edge that connects to the same vertex. So an edge connects to the same vertex. So you just literally go around the way. Okay. If you are ever on the campus of ICC and you're on the third floor, you know that the third floor is one big loop. You can begin somewhere and go all the way around the hallways and come back to where you started. So there is a perfect example of a loop in real life. Adjacent vertices are vertices connected by an edge. Okay, vertices connected by an edge. So in the graph that we have drawn, the one that's labeled A, B, C, D, E, F, G, even though E and G are positioned next to each other vertically on the graph, these two vertices are not adjacent because they are not connected with an edge. However, G is adjacent to F because there's an edge connecting them. G is also adjacent to C because there is an edge connecting G to C. The degree of a vertex is the number of edges exiting, or if you prefer entering, a vertex. It's just a matter of perspective. Do you want to see the edges as going out or going in? When it comes to degrees, we also have even and odd vertices, and so even vertices have even degree. Odd vertices have odd degree. And so let's take a look at the graph, and we will look at the degrees of the different vertices. Now we're going to be looking at, again, this graph up here is the one we're going to be looking at, and I'm going to write the degree of each vertex, and I am going to include this new edge that I put in there from B to D. We're going to include that in our list. So as we're looking at A, notice there is one edge going out of A, going down to D, and there's another one going to B. That means the degree of vertex A is 2. When we look at vertex B, notice I have one edge going toward A. I have 2 different edges going toward D. There is an edge going toward E, and there's an edge going toward C. When you add those up, that is 5 different edges leading away from B, or a degree of 5. For C, again, we can go toward B or we can go toward G, so degree 2. For D, there are 4 edges leading away, 1, 2, 3, 4, so the degree is 4. And for E, the degree is 2. For F, since there's just one edge leading away, the degree of F is 1. And then for G, loops are the ones that often will cause a question, but there are 4 edges. So one edge goes to F, one edge goes to C, and even though you can kind of count the loop as one edge, it would be like, again, here at ICC, walking out of the classroom and you have 2 choices. You could exit the classroom and go to the left, or you could exit the classroom and you could go to the right. And so that is 2 different options, and so G would have degree 4. Any of those vertices that have an odd degree, for example, vertex B and vertex F, those are considered to be odd vertices. All of the others, A, C, D, E, and G, are even vertices because they have even degree. All right, in the last slide of this video, we are going to draw a graph that models the picture shown. Now, in this picture, the green areas here, so these four, this represents land masses, okay? The blue here, okay, that streaks through, this is to represent a river. And then these little guys here, these are bridges, okay, or the gray parts. These represent a bridge going across the river. So we're going to create a graph that models the picture. What we're going to do is we are going to let the vertices represent the land masses. And so I'm going to label each of the land masses A, B, C, D, and I'm going to create 4 points that represent those land masses. And I do not, by the way, have to keep them in the same orientation. I could put them however I want. I could line them up in a straight line. I can do anything I want, but just 4 vertices labeled A, B, C, D. And then I will connect 2 points together if there is a bridge that joins those 2 land masses. So for example, I have a bridge over here on the left that goes from A to D. So I'm going to draw an edge from A to D. I have another bridge that goes from landmass A to C. So I'll put in an edge from A to C. I have a second bridge that goes from A to C, and so I'm going to put in a second edge. There is a bridge from A to B. So again, make an edge. There's a bridge from D to C. Connect those. And then I have a bridge, actually 2 of them, from B to C. And so draw 2 edges from B to C. And there is the graph that models the drawing of the bridges and the edges.